Class, it's Mr. Zimmerman, and today we're going to look at transformations of logarithmic functions. And at this point, this is going to be a review of just being able to identify key information from a function and then be able to apply that to a graph. So let's go ahead and dive in. So they're going to basically tell us that, hey, f of x is shown below. This is the function, and notice I have some points that are being highlighted with black dots. If the black dots weren't there, I would draw on a couple myself. They're provided. Now, I'm going to go ahead and look at the new function k of x, and that's basically what they want me to do. They want me to graph this function using the following rules. Now, if you notice, x minus 1, this is going to be communicating a specific shift. This is going to be a shift right 1 unit. When I look at the minus 4, since it's on the outside, when I subtract 4, this is going to represent a shift down 4 units. So basically, all I need to do is take this information and I need to apply each coordinate. So I'm going to go ahead and use my graph because it's driven. I'm going to go ahead and go right 1 unit, and then I'm going to go down 4. 1, 2, 3, 4. I'm going to put a big old dot right there. I'm going to do this again. Right 1, 1, 2, 3, 4. I'm going to go right 1. Now you can see it's kind of in the middle. 1, 2, 3, 4. Voila. Now I'm going to need a little more information to basically provide a better picture of this sketch of this function. Now I know that this function has a vertical asymptote. So it is originally at the line x equals 0, right? This is pre-transformation. Now what I'm going to do is I need to shift my vertical asymptote right 1 unit. So right now it's at x equals 0. I'm going to shift it right 1 unit. Now technically, I shifted down 4 units as well. But if you move a line that's infinitely up and down 4 units, you're not going to notice it when we examine the restricted range. So right now, I just want you to know basically we did 2 things. Is we moved the asymptote, and then we translated key points. Now we gotta just end our picture. Notice our graph was slowly going to the right. So I'm gonna do the same thing. I'm gonna connect my points and slowly rise to the right. I'm gonna put my arrow at the end to represent that this continues on forever and ever. Now I'm gonna go include the bottom part of my graph as x approaches negative infinity. It's going to touch the asymptote just barely. It wants to get there, but it will never, ever actually be on that line, but we'll get real close in our sketch. And voila, I have a function that's been transformed.